Okay, so we are analyzing graphs of polynomials. We are analyzing graphs. Let me stop here. Okay, so that means you're not graphing, okay? I will give you the graph, and you're going to think about the polynomials in relation to them. Okay. Domain of a polynomial. Okay. Before I get started there, let's talk about something else. What is a polynomial? What is a polynomial? So here's a question. All right. And by the way, when I say what is a polynomial, I mean that in the general sense. I don't mean like, is it a trinomial or binomial? I don't mean like that. So a polynomial in a general sense, okay? Okay, so this is a function, this is a function. All right, so here's a question. So I have three different functions here. Is the top one a polynomial?
Yes.
Yeah, I hope so. It was a trinomial on the test, right? So it's a polynomial. Is that one a polynomial?
Yes.
It is not. This one is not a polynomial. You're not allowed to have variables in the denominator for a polynomial. So this is not a polynomial. How about this one? Is that a polynomial?
Yeah.
Again, no. This is not a polynomial. It's not a polynomial because the exponents cannot be integers. I'm sorry, cannot be fractions. So this is not a polynomial. Oh, there's more. How about this one? Is that a polynomial?
No,
Why not?
because the exponents can be taken and put into a fraction form.
Right. Or you could just say you can't have negative exponents. So this is also not a polynomial. So you can't have fractional exponents, you can't have negative exponents, and you can't have fractions with variables in them. Variables in the denominator. You can have variables in the numerator, you can't have variables in the denominator. So polynomials are actually very well behaved. They're the nice function. Nothing crazy happens on them. Okay? All right. So when we talk about polynomials, it's these nice things. Okay? They don't, weird stuff doesn't happen. It's as nice as they're going to get.
What are those not nice things called?
Other functions. There's all kinds of them. There are rational functions. This is a rational function. Okay? Rational because of the fraction, rational. This is a radical function because of the exponents. Or you can call it, no, just a radical. This is a rational function because the exponents are negative. Okay? All right. So because it's so well behaved, the domain is actually easy. So the domain of all polynomial functions, the domain of all polynomial functions is all real numbers.
Isn't there a weird symbol for that?
Yeah. I'm going to write it three different ways, okay? So you can just tell me it's all real numbers, or you can give me interval notation, negative infinity, positive infinity. Okay, so two ways. You can either just tell me it's all real numbers or negative infinity, infinity. And the weird symbol they're talking about is that R. This is the weird R. Okay? I don't expect to see that. I do want to see all real numbers or negative infinity, infinity. Okay. Range of polynomial functions. This has three options. It's either going to be all real numbers, so it can be all real again, or it's going to be something like y is greater than some number, and or it's going to be less than or equal to some number.
Did you mean to put that less than or equal to?
Yeah. But it's not going to be all three of these at once. It's only going to be one of these. Right? It can't be two of these. It's only going to be one of these. Okay? In the examples today, they're all going to be all real numbers. Because I forgot to put the other type on.
Oh goodness.
That was not smart of me. All right.
Good job.
Okay, so intervals of increasing. Well, I'm not going to really explain the interval part until we get to the examples. But let's talk about what it means to be increasing. Okay? What does it mean to be increasing?
Getting
Okay.
larger.
Huh?
Getting larger.
Getting larger, that's right. So I'm going to give you a mathese definition of increasing. Okay? Then I'm going to try to explain it with an example. So if x sub 1 is less than x sub 2 and f of x sub 1 is less than f of x sub 2, then f of x is increasing.
Which would mean the opposite for decreasing.
Uh-huh. So decreasing looks like this. If x sub 1 is less than x sub 2 and f of x sub 1 is greater than f of x sub 2, then f is decreasing.
So it's still the x sub 1 greater than.
Say it again?
Never mind, I'm confusing myself.
That's my job. And some of you are thinking, what does that even mean? All right, ready? Who sits there? Dylan. Anybody sit over there? Who?
Haley.
Haley. Okay. Haley and Dylan. Okay. Let's say I have a function. Looks like this. Okay? Let's make it bigger. All right. So you don't have to draw this. I'm just giving you an example and I'm trying to explain the definition. Okay? So let's say this is x sub 1. And this is x sub 2. So plug it in, it goes there. So x sub 1 is less than x sub 2. You understand that? So that's this part. X sub 1 is less than x sub 2. X sub 1 is less than x sub 2. That's what I'm showing here. X sub 1 is less than x sub 2. And then I draw it over here. This is f of x sub 1. And this is f of x sub 2. Those are the y values when we plug it in. See how f of x sub 1 is smaller than f of x sub 2?
Yeah.
That's what that means, right? F of x sub 1 is less than f of x sub 2. So we say this function is increasing. Okay, so whenever we look at these functions on a graph, we always look at it left to right. We're in America, we read from left to right. So we read graphs the same way, we read it left to right. As you look at it from left to right, it's going up. That's increasing. Okay. Let's do another diagram. I don't know what possessed me to draw like that. Alright, so here's x1. Okay. Here is x2. So this is still x sub 1 is less than x sub 2. Do you agree?
Yeah.
But look at the y value. So this is f of x sub 1. And this is f of x sub 2.
Technically, that would be less since we're in a negative quadrant.
What? What does that mean? I mean, what does that mean in terms of less than? Here's a question. Is f of x1 greater than or less than f of x2?
Currently, it's greater than.
Okay.
Because
That's
we're in
it.
a negative
That's it.
quadrant, so bigger numbers actually mean smaller.
Okay. So yeah,
Right, so your point
Right.
would also be switched.
f of x of 1 is greater than f of x of 2. That's what we had here. F of x1 is greater than f of x of 2.
Big. What if f of that, or not f of x sub 1 is bigger than x sub 2?
Don't. It says if that's the case. You're not allowed to switch them. Right? So whenever we make a statement like this, we're saying you must have these conditions. If you have both of these conditions, then f is increasing. If you have both of these conditions, then f is decreasing. It's not, let's switch it around. It's, this has to be the case. If that's not the case, you don't have this situation. I mean, you can turn it around and all kinds of things, but I'm saying, if this is the case, then that happens.
Okay.
Okay? It's not, can I fiddle with this? Well, if you fiddle with it, you don't have it anymore.
That's not what I was trying to say. What is it called when x sub 1 is bigger than x sub 2? Is that like any?
It means you got it backwards. Right. Okay. All right. So now we're looking at what are called maximum or maxima. This is the plural form of maximum. So I'll write maxima when I mean more than one. It's not wrong. I'm not going to point it out to you if you put an S on there and call it maximums. Okay, I'll get over it. I might point and laugh at you, but that's about it. All right. So maximum, and I have a very non-mathese definition for this, is a point that is higher than its neighbors. A point that is higher than its neighbors. What do you think minimum would be?
Lower.
A point that's lower. All right. That's a really weird definition. It's kind of like, well, what do I mean by neighbors? Well, let's talk about that. All right. Okay, this function has a minimum, and one maximum. Okay, this function has one minimum and one maximum. Now, here, this is a pretty high point. Okay, it's higher than all these points, right? But it's not higher than the one left of it. It's higher than the one to the right, but it's not higher than the one to the left. But here, here, this point is higher than the point to the left and higher than the point to the right. This one is considered a max because it's higher than its neighbors. This is lower than this one, but it's still considered a max because it's higher than its neighbors. That's all you have to be. You just have to be a little bit bigger than your neighbors. So this one is a minimum because it's lower than its neighbors. I don't care that it's not lower than this one over here. Right? There's a point over here. It's not lower than that. But we only have to be lower than your neighbors. The reason why these are important is because it gives the graph its shape. Right? These little low points and high points give the graph shape. Okay? Like points over here, they're not really interesting. They don't really give it shape. They kind of give it shape, not much. But these really give it shape. These little terms. Okay? So the maximum minimums give it shape. That's why we're interested in it. Okay. End behavior. Okay? So here, I'm not going to really explain it so much as tell you how we're going to write it. This is how we're going to write it. In the previous years, in Algebra 2 and pre-calculus, we wrote it a certain way. And then when you got to calculus, I wrote it a different way. And then you never go back to the way you write it in Algebra 2 or pre-calc. Well, I talked to the pre-calculus teacher, and we decided we're just going to write it the way we write it in calculus. Just learn one way. Why bother learning two ways? Maybe I will learn at the end of this year that we need to do it the other way. We'll find out. Okay, so here's how you write it in calculus. These are the letters L-I-M. With a little x underneath, and there's an arrow pointing to the right, and I'm going to put the infinity symbol, and then the function.
What does lim mean?
It means the limit of the function f as x goes to infinity. Basically, as x goes to infinity, f of x is going where? Okay. And then, we have another one. X goes to negative infinity. F of x equals something else. They don't have to be the same, but let's make them the same for this example. So this part right here is just an example, right? The left side of this equal sign, this part right here, is going to be part of every answer. Okay? Maybe I'll write it for you sometimes. Maybe I won't. But that's going to be part of every answer. None of that's going to change. You're going to say limit as x goes to infinity, limit as x goes to negative infinity, and the function. So it might not be f, it might be g, it might be h. So that letter might change. Okay? But everything else is the same. But what does this even mean? Okay? It's actually a really complicated way of saying the right-hand side. This is the right-hand side. This is the right side. And this, guess, is the left side. Okay? So let's look at some examples we had over here. I'll uncover it in a second. So what's going on the right-hand side over here? It's going down. Okay.
That's negative.
So it's negative infinity. What's happening on this side, left-hand side over here? It's going up. So that's positive infinity. And that's all it's doing. So if I were to use this graph as an example for my answers here, the right-hand side would be negative infinity, and the left-hand side would be positive infinity. That's it. Okay? Now, they're not always opposite of each other. Sometimes they're the same. Okay? Sometimes they're both negative infinity. Sometimes they're both positive infinity.
Look at that bigger graph. If they're both negative, wouldn't it look like an M?
Yeah. So if they're both going down, it'll look like this. Right? They're both going down.
Oh, that's just a parabola.
Yes. Well, it doesn't have to be, though. It could be this. Right? They're still both going down. It's not a parabola anymore.
And it's like an M.
A W. For the positive, it would be a W.
Now it's both going. Okay?
Now it's W.
Now it's a W.
W and a U. The other side, it's a M and an N.
Okay, thank you. All right, zeros. You guys already know what zeros are. They're x-intercepts. Or they're called roots. Okay? So we're going to use all three of these names. Zeros, x-intercepts, roots. Ooh, multiplicity.
Oh, I said that right?
Yes. Oh, sorry.
No, it's
Ugh. Okay. The definition I want to give you is not going to be helpful for today.
July.
It'll be helpful tomorrow, probably. Okay. Or maybe not even this week. All right. So the definition I'm going to give you is, let's see, the number of factors that produce the same zero. I'm running out of space. The number of factors that produce the same zero. I'm so sorry.
No,
I
I'm just
don't
asking-
care.
No, I was just asking you if that's like.
I answered. Did I answer? Did you understand my answer?
Yes.
Okay. Sorry. I was apologizing you had a teacher like that.
Yeah, he tried to make me write letters. That's because it was out.
Alright.
He was like, your F is wrong.
Your F is wrong.
I said,
Your F is
"Why?"
wrong. Here's an F.
I literally said why. I literally said why. Because you just wrote it wrong.
Well, anyways.
Take off points.
F is F.
F is F. Not according to that teacher. My F was not F.
Oh. My wife laughs at my 7.
Do you think you're lying since
Already said
sevens?
them.
That's how I write my sevens.
That's not how they write it in China.
You don't put the line through it?
How
Yeah,
do
they
I
write a
it?
line through it in China. But they would look like this.
That,
That's how I do it.
Looks like a backward F.
that looks like a backwards F.
Yeah.
Okay, but they don't write the letter F in China, so, you know,
Oh,
no
they
distinguish. Yeah, they write Chinese letters.
I wrote that stuff behind your head.
Okay. Alright, let's continue with the math. I forgot what I was doing. Alright, here we go. Alright. This is being recorded too.
Yeah.
Everybody say hi!
Hi.
Wait, will that work? Oh wait, I can't do that. Sorry. Oh, you guys weren't focused anyways. Alright. I forgot.
You're gonna get
I can't put that on
demonetized.
YouTube if I put you on there.
You're gonna get demonetized.
Okay, I'm not monetized. I cannot ask you to watch the videos and then get paid for it.
Oh, now you gotta put my channel description
Okay. I used to put music in there, and then somebody monetized my video because I was using their music. Now I don't put music on
That sucks.
there. Alright. Anyways,
So
what's the
ours-
range? What's the range? Okay, so range is how low does it go? If this is going straight down, and how high does it go? So how low does it go?
Infinity.
Infinite.
How high does it go?
Negative.
Infinity.
Alright. So when it happens like that, you can either write all real numbers or negative infinity. Right? So you can say all real, or you can write negative infinity to infinity. I don't care which one. You can write one or the other. Okay. No, it's not increasing here. Okay, it's not increasing there. Okay, so I'm going to write my answer for interval increasing twice, 2 different ways. Okay. One using interval notation. Okay. So it's increasing this part, right? You agree with that? It's increasing that part.
Yeah.
Okay. Interval notation, that's going to be negative infinity. And look at the x values. Okay. So it's negative infinity to 0. And it's increasing here. It's increasing here. Going up here. So that's going to be 2 to infinity. That little u stands for union.
Oh,
Okay.
I remember those.
That is a math symbol. That's not the actual letter u. Although if you wrote the letter u, I probably wouldn't notice that you wrote u. Okay. All right. Now another way to write this, negative infinity to 0, is saying x is less than 0. Okay. And the union symbol for inequality is or. And 2 to infinity is x is greater than 2. Okay? So I wrote it 2